track that. Great. All right, thank you. We have a rambunctious crowd here. And I changed my title because I thought my other title was really boring. So what I'm going to try to do is kind of regurgitate everything I know about nematodes and raspberries that I've learned in the last 8 years. So bear with me. Here we go. Just brief, you've already heard 2 talks about nematodes. You all know this. Nematodes are important in raspberries. Species will be dependent upon the location. You know, and worldwide, we're talking about root-lesion nematode and dagger nematodes in raspberry. That's pretty much it. And again, you've already heard most of this, but just to remind you, root-lesion nematodes are migratory endoparasites. About 70% of their time are in roots because that's where they're feeding. And the rest of the time they're in the soil. So they move back and forth from soil and roots. And this is the nematode that I'll focus on primarily today. The other nematode, dagger, the major concern with this nematode is that it transmits tomato ring spot virus, which luckily we don't have a lot of here in the Pacific Northwest, so that's not a big concern. You do have Xiphinema bakeri up here in the Pacific Northwest, but it's not widespread. Okay, so this is where we are. I put nematology as a victim of its own success, and that's pretty much, the problem was methyl bromide. We had probably the most effective pesticide ever known to man, right? We had this compound that we could apply almost everywhere, get the same type of efficacy. We never saw resistance. It was a wonderful thing, and we used it for decades. Well, it's gone. And because of that, I think nematologists were a little bit complacent in trying to find other ways to manage nematodes. The next 2 points, there truly are clouds on the horizon. I hate to be the bearer of bad news, but the landscape is, you know, we talked about the landscape changing for the last decade. I truly think it's changing. We have a limited number of products available. I'll show you what's registered on raspberry for post-plant. There's not a lot out there. We have restrictions on the use of soil fumigants. You all know about them, buffers, fumigant management plans, further regulations coming down the pipeline. So there's a lot going on. There was a shortage of telone this year. Everybody knows about it. It's only going to get worse next year. The Vydate plant is no longer operational in the United States, and there's nothing on the horizon to produce more Vydate. So these are, you know, 2 of the major things that you raspberry growers use that really have a tenuous future. So it comes down to alternatives. You know, in a raspberry continuous production system, you know, what are the economics and the effectiveness of these practices? That's yet to be seen. Plant resistance, cornerstone to any nematode management program, well, we don't have that in raspberry. We don't have resistant varieties. So, you know, that's kind of off the table for us. So what are the future methods and targets? All right, before I get into kind of walking you through the raspberry production system and what I know about nematodes, I just want to thank folks up front. First, I want to thank the growers for the dozens of trials that we've conducted on farm. I want to thank Tom Walters, who's been part of this program since the beginning, Lisa DeVetter, Jerry Weiland at WSU and USDA respectively, Trident Ag Products for fumigating our small plots, coming out and helping us, and then several other companies that have funded a lot of the post-plant nematicide work that we've done over the years. Okay, I'm going to show this slide to you many times. And this is how I'm going to work through what I know about nematodes and raspberries. And what I'm going to do is I'm going to follow the production cycle of raspberries and kind of walk you through decisions that you can make as you're going through replanting, establishment, and then maintaining a raspberry planting. All right, starting with sample for plant-parasitic nematodes. Talk about soil versus root samples, and then interpretation of a report that you're going to get back from the lab that you send your samples to. All right, I took some of Jerry's data from his 2013 and 14 survey that he's going to talk about, and I just graphed number of nematodes per gram of root by number of nematodes per 100 grams of soil. And you can see here I can put a line through it. There's a significant relationship, however, it's not very strong. And, you know, one thing I can take home from this is that, in general, if there's a lot of nematodes in roots, there's a lot of nematodes in soil. So if you get back a sample report that has a lot of nematodes, you can pretty much be guaranteed that you have a problem. Where it becomes difficult to interpret what's going on is some of these outliers, where there's lower nematodes in roots, which, like I told you, most nematodes are in roots, but you have these high numbers in soil. So there can be some misinterpretation going on based just upon soil samples, which is what growers use to monitor nematode populations. And I think that's shown here also in the data over here. When I looked at the average number of nematodes per gram of root in Jerry's survey, about 1,500 in roots, 655 per 250 grams of soil. This is compared to what we saw back in 2008 and 9, some work that Tom and I did. Pretty much the same number of nematodes in roots, but much lower soil population. So again, soil numbers are kind of ephemeral and probably aren't super indicative all the time of what's going on in the roots. So what's this mean when you get your report back from Evergreen or wherever you happen to send it? These are Fred McElroy's numbers that he came up with back in 1992 for root lesion nematode. 250 nematodes per 250 grams of soil is an action threshold from a pre-plant perspective, and then much higher than that for post-plant. So if you go back to Jerry's survey, about 30% of the fields he looked at had populations that were above Fred's action thresholds, okay? Also have Baker I here that he had included in that publication, and Americanum. When we look at some of the work that Tom and I did, the numbers we came up with were a little bit lower, but it shows another important thing, that if you take home only a couple things from my talk, soil matters, and obviously it does. These are nematodes, they live in soil. But the ability of a nematode cause damage is much greater on a sandy loam than a silt loam, and that we saw this in some microplot trials that we did down at WSU. So interpretation is difficult, but I think we're getting to a point where we might have enough information to make some more intellectual or informed decisions as far as pre-plant nematode management options. Okay, now we get into pre-plant nematode management. That's where all the action happens in raspberry, right? From a nematology perspective. I'll go through field renovation and fumigation and some of the options that are out there. All right, Lisa already went through this, so I'll move through it quickly. We have these root removal experiments. Pretty much, again, if 70% of the nematodes are in the roots and you leave them all in the soil, that might be a problem. So can we remove that reservoir of nematodes, fumigate, and improve that management practice? So as Lisa said, we went through, we removed roots from some areas, not from other areas. This was what we removed. This is what remained. Then we went into those areas and either fumigated or not. Looked at nematode populations and plant performance. Lisa showed that earlier. And as Lisa said, root removal did not work for us from a nematode perspective. Our main effect of fumigation versus non-fumigation is what came out to be significant in our model. So fumigation worked, root removal did not, at least at this site. All right, moving on. Still another component of field renovation up here is the use of cover crops. This is something that just kind of came about because Tom collected some samples and sent them down to my lab, and all of a sudden we saw that the wheat cover crops that you guys plant either before fumigation or soon after fumigation are excellent hosts for root lesion nematodes. So the idea here is if you do a broadcast fumigation with Telone C35, you get gas escaping from that shallow layer, you put a cover crop in, those nematodes can colonize those roots while the soil's still warm, and then overwinter on that cover crop. So what role does this play, in supporting nematode populations through to the next planting? I don't think we quite understand it yet, but we certainly know that this is a potential problem for you guys. So we're going to try to look at other cover crops to see. We do not want to tell you not to plant cover crops. That's not what I'm trying to tell you. I'm telling you that wheat is a host for root lesion nematode, and what we're doing is looking at some other cover crop species that might fit into your system. So same idea, fumigate, have a fall planting, winter cover crop through, till it in, and be able to hill and plant in the spring. So we have black oats, wheeler rye, and a tall fescue, and Lisa mentioned these earlier as well. So that's a picture of our trial, I think a couple of weeks ago. All right, moving on to fumigation. So you've done your renovation. These are your options. I always said I became a nematologist so I wouldn't be like Tim Miller and have a whole list of compounds to talk about. So I have 4 that I can tell you about. We have 1,3-dichloropropene. Okay, again, shortage last year. They're sending it overseas. I don't know what's going on with as far as it's a byproduct of the plastic industry, so there's not a lot out there. It's probably going to become even more hard to find next year. It's a widely used fumigant. You know, raspberry growers aren't the only ones using it. You know, the potato guys love 1,3-D. We got Vapam, which is metam sodium. So what your neighbors to the north use primarily, that and Bazimid. Kpam, which I haven't heard a lot of use. And then the new biofumigant Dominus, which is an aloe ITC. And again, your goal with fumigation is not to, you know, completely annihilate nematodes, is to bring their populations down so you can get a plant established and so that you can have a productive planting over the life of the planting. Okay, so you have a few options when you start thinking about fumigation. First is type. What are you going to use? We've done 2 trials here recently where we evaluated different types of fumigants. And I just want to show you some of our really promising results. This first field fumigated in September 2014, and then we collect samples in spring and fall of each year. And we have Vapam in this trial, Dominus, and Telone C35. We look at nematodes per gram of root, and the really positive thing is right here. 2 years after fumigation, Vapam's doing a very good job in what I consider to be a very heavy density field here in Whatcom County. So that's really great news. We might be able to use something other than Telone C35 and get good nematode control. This is similar data to what Lisa showed earlier today. It's a trial we had that was fumigated in September 2015. This is data from this past summer. And the good news here is that our fumigation did really well. So Telone C35, C35 plus Tarped, and Vapam all performed really well. Low numbers of nematodes and roots. This field had about 3,000 nematodes per gram of roots before fumigation, so you can see it did a really great job. So we'll continue to monitor this. But again, it's telling us we do have options above and beyond just Telone C35 as a flat fume, no tarp. All right, tarps and bed fumigation. This is something that Tom and I have been kind of chipping away at for the last 8 years. So in these trials, we had 3 trials here, 2 trials in Linden, 1 in Skagit, where we evaluated bed fumigation compared to broadcast fumigation. And some pictures here, we did have a tarped bed fume as our new treatment versus the flat fume, which is right here. And real quickly, this is the data. Linden site 1, site 2, here's soil, nematode populations per 100 grams of soil, root nematode populations per gram of root. And again, some really encouraging data that, you know, I'd really like the industry to take a close look at. These were fumigated in fall 2010. So this fall 11 is 1 year after fumigation, 2 years, 3 years. And when you look at the soil populations, both treatments gave really good suppression early on. But then as you got out about 2.5 years, you can see that the bed fumigation continued to keep nematodes at bay. Okay, this is a bed tarped application. In this field, which is when we looked at roots, we saw kind of 2 different things happening, but we certainly saw that overall bed fumigation did a better job than broadcast fumigation in short and long-term suppression of root lesion nematodes. So we do know that this can be a superior treatment to just a flat fume Telone C35. The other thing that we looked at here that I'm not showing any data of, we looked at root lesion nematode populations in the alleys, and they were essentially non-existent. So this idea that nematodes that remain in the alleys are going to migrate into beds, I don't think is founded based upon our data. All right, so we know bed fumigation is good. And then finally, something that a graduate student of mine did a couple years ago was to look at fumigant efficacy in a couple different soil types up here. So we went to 2 different fields. We sampled down to 3 feet prior to fumigation, after fumigation, and at planting. So we could see where nematodes were surviving within the fumigation Telone C35 system. And I just have 1 graph from that. And again, this is, again, if you take home something, it's soil matters. Can we generate recommendations based upon soil up here in Whatcom County? I think we can. So what we see here, these both were flat fumed Telone C35. Here's a loamy sand, 70% sand. Here's a sandy loam, 52% sand. You can see what's going on with my circles. So This field had a lot of nematodes, very shallow. And here's our pre-fume, which is blue. Our post-fume, which is kind of this orange color, and then at planting is green. And you can see our nematodes survived after fumigation at these shallow depths. So this, we shank injected at about 18 inches. The fumigant moved up through the soil, and with that sandy soil, it all just kind of raced through those top 3 to 4 inches, right? So that's where we get all this survival. In this heavier soil, what we saw is that it did a really good job of holding the soil fumigant here shallow above where the shanks went in, but we missed what was down low because, you know, a gas doesn't move down, it moves up. So what this is telling me is that C35 flat fume is probably a decent method for this field, whereas I might just go with a VAPAM cap in this field. If I have nematodes that are shallow, I know I need to treat that top 6 to 9 inches, that might be a candidate field to move to a VAPAM type application. Okay, moving on really quickly. Plant material selection. I've shown you this data before. We did experiments in 2010 to 12, looked at a bunch of different varieties, planted plants in areas with and without nematodes, so fumigated and non-fumigated, and this is our harvested fruit yield. This is a second or third year crop, and in orange is yield in fumigated plots, red is yield in non-fume plots, and it's pretty obvious what's going on. Nematodes hammered these plants. And there's the proof. Cascade Bounty, Meeker, fumigated on the bottom, non-fumigated on the top. You know, so, you know, growers fumigate for a reason. You know, they've probably seen failures like this when they haven't fumigated. So certainly nematodes do have the potential to cause a tremendous amount of damage during the establishment phase. This was a high pressure field, so probably seeing this type of thing, I don't think you guys are going to see. This is really an extreme case, but it kind of really demonstrates what nematodes can do. All right, plant establishment and health. We haven't done much here. All I can say is get your plants up and going and try to help them outcompete nematodes. Lisa and I would like to do some stuff with nitrogen, looking at nitrogen levels and how they impact nematode parasitism in the plant to overcome nematode parasitism, but we haven't looked at any of that yet. All right, and then finally, post-plant nematode management. So you have your plants in the ground, and you want to continue to keep nematodes at bay to maintain a productive planting. What can you do? So this is what I got off of WSU Pickle just a couple weeks ago. So this is what is listed as nematicides on raspberry in Washington. I personally haven't heard of most of these. The only thing that we have personally looked at is Vydate, and I'll tell you a little bit about that. But otherwise, you know, everything that's listed up here probably has not been tested in Washington raspberry. And I do have a disclaimer here that I'm just presenting what I found online, and I'm not making any recommendations, but this is what's out there. So we do know that a post-plant nematicide application will not rescue raspberries. All right, so if you go into a 3 or 4 year old planting, you have nematodes, you know, your yields are dropping, you're like, I'm going to try to fix this with, well, I'm not sure what you're going to fix it with, but if you tried to fix it with something, just the nature of a perennial crop, you can go in and take out nematodes and hope to see a yield bump the next year or the next year. We just never saw that. So in this trial we went in, we took out nematodes with products that aren't labeled in raspberry. We pretty much had 0 nematodes versus a lot of nematodes, and we never saw that yield bump of getting rid of nematodes. So, you know, either you guys grow raspberries so well that plants are able to compensate for all those nematodes, or, you know, you just never kind of got the plant to reset its carbon dynamics after the nematodes were gone. I'm not sure what is happening, but this expectation that you can rescue a planting with nematicides, I don't think is a real one. What I'd like to see as we move forward with post-plant nematicides is, you know, I don't want to become a program person, but I do think if we're going to implement post-plant nematicides, it's going to have to be at the start of that planting, and it's going to have to just kind of keep up with that planting and keep nematodes at bay once we have a product that actually works. So as you know, you have a label for Vydate on non-bearing raspberry. It can be applied within 12 months of harvest, so pretty much up through June here in Whatcom County. It's a banded application, forfeit application. They're modifying the label, as Tom said, to include a drip application on there, so check that out. I don't know how much Vydate you're going to be able to find. That might be a problem, but if you find it, I do think it's a useful tool as a non-bearing application. We had a couple trials here in a wake field and a meeker field. What we were looking at was when was the best time to apply Vydate. And we applied in May, in June, and then we had a control, 2 different fields, kind of a high-density field and a low-density field. And, you know, this is the same kind of thing. In high-density fields, we can knock nematodes down, but they come back very quickly. In low-density fields, we can knock them down, and we can keep them at bay a little bit longer. And you see that here. We got a significant reduction early in this high-density field and then lost it. In this low-density field, they were kind of low, 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 and then all of a sudden we saw differences with our Vydate application and our non-treated. So again, soil type matters. It also matters how many nematodes you have, okay? And we're seeing that consistently across our trials. And then finally, last slide on what I know about nematodes in raspberry. We are doing nematicide trials with a few compounds that are not labeled on raspberry, so I'm just going to call them compound 1, 2, and 3. Not seeing a lot of positive results up to this point. These red arrows show where we did applications. This is the number of nematodes per gram of root. It's a high density field. Again, we have a lot of nematodes here. We did get a treatment separation with compound 3 this past fall. This product, we're not seeing anything. The recommendations from the manufacturers can be anything like spring applications or spring and fall applications, so we're kind of messing around with that right now. These are all drip applied products. So we continue to work on this, and this kind of goofy data, for lack of a better word, is the same thing that I see in my grape trials. We're really struggling to get these nematicides to work in a perennial system. All right, so conclusions. That's what I know about nematodes as you work through the raspberry production system. And my goal kind of in this coming year is to work with Lisa to get some of this information out there, because I think we are at a point where we can make a few more informed decisions on certain things in the raspberry production system. And just a summary of when I went through ability of practices to manage nematodes. Sampling, yes, obviously you need to sample to figure out if you have a problem. Root removal, no, our data is not supporting that this is a viable management practice at this point. Fumigation, broadcast, yes. Bed is great. What about a drip termination application? We haven't looked at that yet. That might be a nice thing to reduce buffer size. Cover crops might be making the problem worse, although I'm not advocating not using cover crops. Plant selection, no, that's not an option. Plant health, yes. Non-bearing nematicide, I do think Vydate is a good product for you guys. And then bearing nematicides, it's left to be seen if we're going to have a product that actually works in raspberry. So with that, I'll finish off and take any questions. Yes?
It does a hilling too?
Yeah, it does. The question was the bedding machine does hilling. Yeah, it does.
So if you're going to do hilling, then it's that much easier just to do a bed tarp, and you're using half the amount of chemical. Right?
Yeah, so I should have pointed out, there's a lot of advantages to a bed application with the tarp. I mean, your bed's already formed coming into the spring. You have a tarp on it that might make it easier for it to get in and plant earlier. Those are all positive things. Trident now has a bed fume rig that they're using. I've seen it several places around. So, sorry, but it's not tarped, correct? Yeah, and the reduced rate. I mean, you go from having, well, it goes down to a 25-foot buffer on a bed fume. Yeah. Mm-hmm. And you don't have to do that thing where you're splitting the field up and fumigating chunks. Yeah. All right. Well, thanks for coming. Jerry's, all that is between us and beer. So.
Thanks, Inga.